Lesson 4.3 is going to start us talking about parallel and perpendicular lines. These vocabulary terms we'll talk about in a second really are just another way for us to identify the slope. So if we remember point-slope form and slope-intercept form, both of those things have slope in their name, which tells us what they need. So if perpendicular and parallel are a way for us to figure out the slope, well, we should be able to write an entire equation of a line if we know a point and that it's supposed to be parallel or perpendicular to something else. So parallel lines really have two main points about them. Parallel lines should have the same slope and a different y-intercept. Real quick, let's talk about why this is important. Some of you might understand parallel lines as two lines that never cross. Well, for them to never cross, they have to be able to go up at the same rate. Otherwise, eventually they'd get closer and closer and closer and cross eventually. The different y-intercept part is to make sure they don't start crossing to begin with. If I have the same slope and the same y-intercept, well, that's the same line. And if I have two of the same line, well, they're just drawn right on top of each other. So there's actually two lines here. That's not parallel lines. They might have the same slope, but the fact that they're the same exact line means that that never cross thing isn't true. So that's one way to think about it, is that they never cross. But what does that actually mean for us in algebra? It means these two things, same slope and different y-intercept. The example from your book for the first parallel lines example has these lines. I didn't draw mine perfect, so the lines probably might not look like they're supposed to, but they all look like they could be parallel based on where the points are. The idea here is we need to check each of their slopes. The fact that none of them are on top of each other, we're good on the y-intercept thing. We're just going to check for any lines that have the same slope. So they label these lines, I guess they don't have, yeah they do, A, B, and C. So let's check the slope for each of those. So for line A, if we do our slope formula, remember that's y2 minus y1 over x2 minus x1. I'm going to do 2 minus 3 over 1 minus negative 4, and I get a fraction of negative 1 over 5. Now for line B, I'm going to do negative 1 minus 0 over 1 minus negative 3, and I get negative 1 over 4. So A and B are not parallel. Even though their slopes only ever so slightly different, their slope's still different. They need to be the same, exactly the same. Negative 5 minus negative 4 turns into negative 5 plus 4. 2 minus negative 3 turns into 2 plus 3. That's negative 1 over 5. Well, we found a match. So in this situation, A and C are parallel. The way we were able to tell, they have the same slope, and just by looking at the graph, we can tell that they're not on top of each other. So lines A and C are the parallel lines. This is going to be a more typical example for us this unit. They give us enough information to write the equation of a line. Now, we have two situations. We can either have point-slope form, or we can have slope-intercept form. Do you remember the difference? Point-slope can use any point, doesn't matter. Slope-intercept requires the y-intercept. The point they want us to go through is not the y-intercept because it's not 0 comma something. So we're going to go with point-slope form. It doesn't tell us which one specifically, so we're just going to go with the one that's easiest. So that's y minus y1 equals mx minus x1. So we have the point. We have the point. This is going to be x1 and y1. But where's our slope? Well, that's what parallel tells us. That's what I was talking about on the first slide when I was talking about what we learn about for the day. If I'm parallel to this equation, parallel to this line, I need to have the same slope as this line. Well, parallel to 2 means m equals 2. Now we have everything we need. Fill in my x1, y1, and m, and that is a successful point slope equation. Now let's simplify a little bit. Instead of minus -4, I can do plus. And this is a perfectly acceptable answer. I will take it one step further, though, and get it into slope-intercept form. Distribute. Subtract 4. Bam. Same slope, different y-intercept. Y equals 2x, that's where they match. And then plus 3 and minus 14 is where they're different. So they'd both be lines that go up at a rate of 2 over 1. But one's down here, one's up here. Perpendicular lines have a little bit different information. It's still talking about the slope. So there's two ways to think about perpendicular. The way you probably understand is they make a right angle. They make a perfect corner. So they would make a perfect corner. That's usually what we use that little square for, to show a 90-degree angle. Well, those should be perpendicular. Now in algebra, unfortunately, that's not the most useful tool for us, so we need another way to do this. The slopes are opposite reciprocals. Now inside that definition, there's a couple other vocab terms, opposite and reciprocal. Opposite means you flip whether it's positive or negative. Reciprocal means you flip the fraction. So let's write a couple of opposite reciprocals quick, just so that we make sure we understand what that means. If I have a slope of 2/3, perpendicular to that, perpendicular would be a slope of negative 3 over 2. That's all there is to it. This one was positive, I made it negative. This one was 2 over 3, I made this one 3 over 2. Those lines would make a perfect 90-degree angle. All right, now if I have a slope of like m equals 2, well, the perpendicular slope is negative 1 over 2. How can I flip the fraction if there isn't a fraction? This is when I'd hope you'd draw back on your prior math learning and realize you can put a 1 under any whole number to make it a fraction. So it's perpendicular slopes. There's a little more work to do than parallel because nothing's easier than just saying, hey, steal the one that's already there. But this is all we have to do. There's no actual calculating. We just have to remember these changes. This is something to memorize. It's part of the definition of perpendicular. This is something that's hard for me to just get you to understand. Unfortunately, it's a vocab term, and that means we have to memorize what it's telling us to do. All right, we know the lines should look like this, so that's a way to check our work once we graph them. But we have to memorize this vocabulary term to be able to use it. Here's another pretty typical kind of problem I might ask you to do for a unit like this. We have a few equations, and we're supposed to tell which ones are parallel or perpendicular. So the goal here is to get them all into slope-intercept form like A already is. All right, this is where if you're still struggling with your algebra steps, you need to come ask me and get help, because you're not going to be able to answer a question like this, regardless of whether you know what perpendicular and parallel mean, if you can't get the right equations. So, letter B, our goal is to get y by itself. I'm going to minus x on both sides. 4y equals negative x plus 3. Divide by 4. Y equals negative 1/4 x plus 3/4. So now we have letter B in a form where we can analyze it. And letter C. Add 2x on both sides. Negative 8y equals 2x plus 16. Divide by negative 8. Y equals 2 over negative 8. I can simplify that to 1 over negative 4. So it's negative 1/4 x. 16 divided by negative 8 is negative 2, so minus 2. All right, now let's try and do this systematically. M equals 4 for letter A. Parallel would also be 4. M equals negative 1/4 for letter B. Those aren't parallel. M equals negative 1/4 for letter C. Well, B and C are parallel. We can say that right now. B and C are parallel. There's a shorthand way of writing that too, which is just B parallel to C. That's what double lines like that would mean. But I'll write out the words for now. B and C are parallel. Okay, well now what would perpendicular look like for 4? Perpendicular is opposite, so it'd have to be negative, and reciprocal. So instead of 4 over 1, we'd be looking for a negative 1 over 4. So A is perpendicular to both B and C. They both have a perpendicular slope. A and C are perpendicular. A and B are perpendicular. So just comparing slopes. So we're similar to the other example where we wrote a parallel line through a point. Here's our point. Here's the equation we're supposed to be perpendicular to. It's got a slope of 1 over 2. But now we're supposed to be perpendicular to this. So we're going to go with point slope form again because I don't have the y-intercept. Y minus y1 equals m, x minus x1. That's what we're filling in. So I've got my x1 and my y1 from the point they tell me to go through. And here I have a slope, but I'm supposed to be perpendicular to that. So what would perpendicular look like? Well, opposite would be negative, reciprocal is flipped fraction. So negative 2 over 1, or just negative 2. That's the slope we use, and we use the x1 and the y1 from the point. So now let's fill in. Y minus y1 is 1, equals m is negative 2. Then in parentheses, x minus x1, that's a negative 3, so x minus negative 3. Now let's simplify this. X minus negative 3 can be x plus 3. And that's a perfectly acceptable answer. But again, I'm going to take it one more step because I do like slope-intercept form better. So I could distribute. Y minus 1 equals negative 2x minus 6. Then add 1 on each side. Y equals negative 2x minus 5. These two lines, if we were to graph them, would be perpendicular and make a nice right angle. So you might look at that a little bit on Desmos when we do this in class.